Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course, Statistics 101, Introduction to Statistics. In less than 10 minutes, this video explains the difference between parameters and statistics. Let's get started. Now, as we discussed in previous lectures, statistics essentially involves using sample data to make inferences about an entire population. We don't want to get data from every member of the population. That's just too costly. What we want to do is get data from just a portion of the population, and that portion is what we call a sample. This is more effective from a time perspective, from a money perspective, and also from a manpower perspective. Now, sometimes, the conclusions or inferences that we reach are going to be about the characteristics of a population or how the population is right now. But oftentimes, the inferences or conclusions we make are going to be predictions about the population or how the population will be in the future. Either way, we can use statistics to get those inferences and conclusions. But in order to do that effectively, we need to know and understand a few definitions. First, we need to understand the difference between a parameter and a statistic. A parameter is simply a numerical measure describing some characteristic of a population. On the other hand, a statistic is a numerical measurement describing some characteristic of a sample. So, parameters go with populations and statistics go with samples. It's really important you get this down because oftentimes the proper use of statistical methods requires, us to distinguish between populations and samples. So, the way I keep them straight in my head is with alliteration. Notice population and parameter both start with the letter P. Therefore, I know that those two are associated together. And likewise, sample and statistic both start with the letter S. So I know the statistics are used to describe samples. Now, you can usually tell whether or not something is a parameter or statistic just by looking at what it describes. Are you looking at a population? That's a parameter. Or are you looking at a sample? That's a statistic. Here's an activity that will help us to hone down this distinction between parameters and statistics. I'm going to give you some examples, and then you're going to tell me whether it's a parameter or a statistic. Now remember, in order to learn more effectively, you must participate in active learning. That means involving yourself with the content. So I'm going to pause briefly to allow you to respond when appropriate, and you can use that space to make your responses out loud. Now, there is something that turns the brain on when you say something out loud as opposed to yourself inside your head. So, go ahead and just say the answer out loud. You want to reinforce good learning. Okay, here we go. Your first example is this. In a traffic safety survey, 21% of respondents said they recently texted or emailed while driving. Is this a parameter or is this a statistic? I'll give you a few seconds to decide. Well, I hope you said statistic because that's the right answer. 21% of respondents is not the whole group. It's just a portion of the whole. Therefore, we have a sample because it's a portion of the whole. And since we're talking about a sample, that means we must be talking about a statistic. Here's the next example. There are 50 state capitals in the United States. Is this a parameter or a statistic? Again, I'll give you a few seconds. Well, I hope you said parameter because that's the right answer. 50 state capitals is all there is, so that's the whole group. And since we're talking about the whole group, that means we have a population. And populations are described with parameters. Here's the next example. A study examined all 2,223 passengers aboard the RMS Titanic. Is this an example of a parameter or a statistic? I'll give you a moment. Well, here we're looking at another example of a parameter. We have all the passengers aboard the ship. That's everybody. That's a population, and therefore we're looking at a parameter. Speaking of the Titanic, there's this really interesting conspiracy theory that says the ship at the bottom of the North Atlantic is not the Titanic, but rather her sister ship, the Olympic. Now, I'm not usually one to give much credence to tales of conspiracy, but this one is interesting enough to merit some consideration. And even if it's not true, it still sounds pretty plausible, like it could be true. So why don't you take a look at that if you're interested? Here's our next example. The mean volume of brains in a neurological study is 1,126.0 cubic centimeters. Is this an example of a parameter or statistic? I'll give you a moment. Well, I hope you said statistic, because that's what this is. Now, don't look at what's actually being calculated. The mean is just a statistician's way of saying average, but you don't want to look at that. Look instead at the actual numbers in the data set. Do those numbers represent a sample or a population? We know this is a sample because we're talking about brains that are involved in a neurological study. No neurological study is going to study every brain in existence. We're only going to look at a portion of all the brains in existence. So we don't have the whole group, rather a portion of the whole group. That means we have a sample, and samples are described with statistics. Here's the next example. The mean atomic weight of all elements in the periodic table of elements is 134.355 AMU. Is this an example of a parameter or a statistic? I'll give you a moment. Well, I hope you said parameter, because that's what this is. All the elements in the periodic table, we've got them all. So we've got the whole group. That means we have a population. Populations are described with parameters. Here's another example. In a random sample of households, 47% of households had HDTV. Is this an example of a parameter or statistic? I'll give you a minute. Well, not a full minute, but yeah, you know what I mean. Okay, I hope you said sample. Here it is. It's right here in front of you. In a random sample. Did you catch the word sample? I mean, there's your clue right there. I mean, we're talking about a sample. Now, even without that clue, you know this is a sample because you're looking at 47%. That's not the whole kit and caboodle. It's only a portion of everything. So you could deduce from that figure we're talking about a sample. But anyway you get there, samples are described with statistics. You know, sometimes you'll get examples that just say the word outright. And that's a freebie, man. When it comes to you, just say thank you. Then take your freebie. Yeah, just take it and run with it. Remember, statistics are used to describe samples. Parameters are used to describe populations. And that brings us to the end of this mini lecture. I hope you found it helpful. If you'd like more practice with this topic, check out the next mini lecture. And as always, you can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching, and I'll see you in the next video. Howdy peeps, I'm Professor Curtis of Aspire Mountain Academy, and I hope you enjoyed this free sample mini lecture from my Stat 101 course. This is a course that I've worked really hard to develop. It's taken me a while to get through it, and I hope you enjoyed this free lecture. If you want more like this, then you need to sign up for my Stats 101 course. So go to the link there in the description down below the video. If you like this video, go ahead and give it a like. And subscribe to the YouTube channel, and I will see you in the next video.